Okay, so the idea of these portals, they work like this. I'm inside a level, I'm going to have a trigger that pushes me forward to the next level. So since the village is the one that is the central environment, I have a connection from the village to all the other portals. So here in the village I create 4 portals, you can see here. Portal to garden, to beach, to castle and to farm. 1, 2, 3 and 4 portals. And for all the others I just need one, so that brings me back to the village. So from farm, from castle, from garden up there, right there, and from the beach right here at the bottom. And these are pretty simple. Let me open one of them here. Is just an empty with a box collider 2D set as a trigger with whatever size I want, and the portal script that we are going to be writing next. All of those share the same portal script, and that's pretty much it. The one thing I did, I went a little bit far, is that I also wanted to show the name of the level, the name of the environment that we are. So I created another parameter that I call it the region name, and whenever I jump into a specific environment, a specific region, I'm going to show for a couple seconds the name of the region I'm walking into. So to make the game a little bit more interesting. So for that, I need a canvas. So for me to create a canvas is pretty simple. I go here to the plus sign, UI, and then you have all the components for the canvas. A canvas is just a layer that we put on top of the camera to display 2D imagery. Some people call this a heads-up display. So 2D data that is going to be displayed on top of the camera. So it doesn't matter if the camera moves around, the canvas will always be visible because it's placed in front of the camera. In this case, what we want is a text. In this case, we are using yet another package from Unity called Text Mesh Pro. So the first time you are adding this to your application, Unity will pop up with the package manager, will ask you to install the package. And just like before, we also are allowed to install samples if you want to learn more. But installing the package itself is mandatory if you want to use these components here that contains the word Text Mesh Pro. So this case over here and the text over there, that's the one we are using right now. Okay, so I did that already for videos, in between videos. So I have my canvas here with the region name. Let me double click. By the way, if you double click the canvas, you are going to get another rectangle that is much bigger than your actual level. See, my level, my entire level is now resumed to a tiny region over there. Don't worry about that. It's just because the camera works in a different space than your game environment. So this region here is going to work in pixels rather than Unity units. So in my case, let me scroll up to get more of the camera. I create an image. So same thing, UI, image, and then I put my own logo over here in the upper right corner of the screen, because I found it would be nice to have that, look like a more professional. And I create a text, and I put the text at the center of the screen, like so. So for me to put the center of the screen, you select here in the inspector the custom area. If I hold Alt key, you are going to get an anchor. See, the anchor is basically where you are going to place your objects on the screen. So in this case, if I choose this one at the center of the screen, my object is going to be placed right there, or any corner. You can choose whatever you want. The thing about working with canvas, you need to remember that you don't know what kind of device your game is going to be played. It could be a computer that has a very large screen, or could be the screen of your mobile device that is a very tiny screen. So everything that you put in your canvas, you don't know how many pixels you want to you will have available to display that image. That's why you need those anchors, because those anchors, they will store all the information on the canvas as proportions of this rectangular area over here that represents the canvas for you. So when Unity is going to render your game, Unity will detect the actual screen resolution of whatever device you are playing the game, and then it is going to render all your images, text and whatnot in the canvas as proportion of those screen. So instead of saying my text is 100 pixels wide, is going to say it's 30% wide. So if I have a screen that's 1,000 pixels, it's going to be 30% of 1,000. If I have a screen that's 100 pixels wide, it's going to be 30% of 100. So it's a much smarter way of guaranteeing that your text, your images, or your heads-up display will always show in the right proportion, regard of the size of the actual screen you are playing the game. Okay, so as soon as you do that, you want to come here in the canvas object, and in the canvas object, if I scroll down, you have canvas scalar. By default, it's going to be constant. You don't want, I just said that you don't want your canvas to be constant, so you change this to scale with screen size, and then you provide here a proportion. Normally what I do, I just change the match to half the way, 0.5. What this is telling Unity is that I'm going to squash horizontally all my canvas components in half, and vertically all my canvas components also in half, so they match the screen size. If I change this to width, they will adjust to the width of the screen in detriment of the height. So it might be a little bit distorted vertically, or if I change this to height, it does the opposite. It adjusts to the height of the component in detriment of the width, and it might be look a little squashed. So if you split the difference 0.5, you are distorting horizontally and vertically by the same scale factor. So this way the components are always going to look in the same proportions when you are designing your canvas. Okay, so now that we have a region name, I adjusted this size here to a specific size I want, and then you have to specify what you see. You can even type a test message just to see how this message look like. So whatever you put here in the text box is going to be what is going to be showing on the screen, as long as it fits inside this rectangular area. If it goes a little further, it starts shrinking the size of the text, because I checked the auto size option. If this is unchecked, it's going to start leaking outside the region of the text. Okay, so in our case, what we are going to do is just to write a single word, is the name of the environment, so it won't matter. This is wide enough for our purpose. So I made it bold, I made it centralized, and here at the bottom I changed the outline, the face text to be black with a yellow outline. So if you write a region name, you'll notice what I'm talking about. It's black with a outline in yellow, and you also can change here the thickness if you want to make more or less thick. It's all I trust your good sense to make things prettier in your game. By default, mine is going to be empty, because I only want to show this whenever the player is swapping from one level to the next. Okay, so that's what the canvas do, and now we need to use that in our script. So in the script, I came here and create a script called Portal. So let me double click this script, and let's see how we work with the portal. So first of all, we are using the package Cinemachine. So including using Cinemachine, we are using the package TextMesh Pro, that's abbreviated by TM Pro, with the first three letters capitalized. So it's mandatory to have this both in your script, because we are going to be using that. Something new here, I'm declaring an enum. So enum is basically a new data type that we created, because my idea is to determine which direction I want to push my player depending on the position of the portal. I might want to push the player up, down, left, or right. So in this case, I created a data type and I store these 4 labels. What enum does is basically associate each label to a number. That's why enum, from enumeration. So up means 0, down means 1, left means 2, and right means 3. So instead of using 0, 1, 2, 3, I use these labels, which are much more readable in my code than using just numbers. So if I said direction equals 2, nobody will understand. So this way it's easier for us to understand our code. But this is just a data type. I need to create a variable of this data type. And that's what I did over here. I create a variable called direction of type direction. And I initialize with one of the labels. It could be any one, because we are going to change that in the inspector. So in this case, type that direction is direction up. Something new also here, we are going to use what we call a compilation directive. Is this square brackets. So a directive means that we are changing the ways how Unity operates, how Unity works in a code. So whenever you're using these square brackets, we are modifying Unity, not modifying our code. So by default, Unity will only show in the inspector variables that are declared as public. But I don't want to make these variables public. I want to keep these variables private. So, but I want the variables, even the variable being private, I want them to be displayed on the inspector. So I use this serialize field. So it's a private variable that I can add it in the inspector. So for all 3 variables, I did this. The collider is a reference to the new boundary where the character is going to be jumped into. The direction is which direction I should push the player. And the force is how strong I want to push the player forward. Again, I initialize these with dummy values because I will change those values in the inspector later. That's why I'm serializing those fields. I also did the same for the name of the string I'm supposed to display whenever the player walks into a specific region. And I need a reference to that canvas component we created earlier, where I'm going to the actual display the value. It's a text mesh pro text value that I have over there. Okie dokie. So those are the variables I create. Yet another novelty is we are going to be using a property. A property is a special type of class member because it's a variable that I can define how I'm going to read and write content from the variable. So in this case, I create it is public, a vector3 direction. Note that my local variable is lowercase d direction. This property is uppercase direction. So they are 2 different things. One can use the other, but they are not the same information. So what this property does, it's allow me to implement a get and a set method. A get method tells me how I should retrieve data from this property. A set method means how I can initialize this variable with another value. So if I implement a property that only has a get method, like this one, so that's a read-only variable. I cannot modify the property because I don't have a set value. If I implement a property that only has a set value, I cannot read the content, I can only set the content. And of course, I can do both. I can do gets and sets, and then I have a regular property that I could read and write. So one is for reading, one is for writing, and I can use either or. And what I did here, I created this direction that only has a get method, so I can only read this method. So what this does is to create a switch case and check if the direction value over here is up, down, left, and right, and I initialize mathematically with the correct vector, up, down, left, and right. So this is the actual direction I'm supposed to push my character forward. So whenever I change here the lowercase direction, this is going to change as well and contains the proper vector in the direction we are looking for. So I can use this capital D direction in my calculations, and I don't need to worry about setting this variable because the property here will set the variable for us. Okay, so I also have, what's that? I also have a reference to the confiner that I'm going to be updating, and this variable dir I created here is just a temporary variable that I use to compute the property direction. The initializing start method is just for me to initialize the confiner. Just to remember, the confiner is this guy here in the camera. Cinemachine confiner we created earlier. I need to find a reference to this guy. Since I know that I only have one camera in my level and that's the only component that is going to have a Cinemachine confiner, I could use this find first object by type Cinemachine confiner, because I know I will only get the same response. I only have one in my entire game. So this Cinemachine confiner here is going to be returned from the camera we created earlier. So this is a reference to the object that we are planning to change every time our player jumps from a portal to the next. And the way for us to do the changing is nothing new. We are still using the proximity detection. So on trigger enter 2D, we are going to check if the entity, the game object entering the trigger is indeed the player. If it has a tag player, then we swap the boundary to that new boundary we are defining here. So let's say I'm the village and I'm the trigger to the garden. So the new boundary is going to be the garden, the boundary. So my camera now will be confined within the boundaries of the garden instead of the boundaries of the player. And I need to push my player up, so the player is now inside the garden rather than inside the village. So again, it's pretty standard. We did this already a couple times. So I get the current position of the player, I update the position, multiplying direction by push force. This time it's not an animation, so I don't need to multiply by time. Data time is just a force that I'm pushing the player in that specific direction. And then I update the position of the player back in screen. And lastly, I need to show the name of the region a couple seconds on the screen and then delete it. So for us to do that, I cannot use a routine that it keeps playing a loop, otherwise my game would be frozen waiting for the loop to complete. So instead of that, what we do, we use what Unity calls a coroutine. So we create a coroutine, and for us to create a coroutine, we declare it with this keyword IEnumerator. So it's basically a special type of function that runs in parallel with Unity Engine. So whatever it's running inside the enumerator is not going to interfere with the proper work of my game at all. So what I did here in the show region, I set the content of the text to the region name we create over here, the text. Then we are going to wait for 2 seconds. See, yield return new wait for seconds 2. So it shows the content of the screen for 2 seconds, and then I update the content back to empty string. So the text disappears. So yeah, and this coroutine is going to be working in parallel with whatever else is going on in my game. So this is not going to interfere at all with the game, and we are pretty much done. We have now a routine that runs in the game. Let me go back to my document. So if I go now to my camera bounds, I create several portals, each portal going to have a direction, a push force, name of the level that is going to be. Let me double click so you can see in the level. So I'm here in the village with a portal pushing me forward to the garden. So it's going to be pushed up to the garden and get a reference to that canvas component. And the same thing goes if I'm in castle and I want to go back to the village, like so. So I got this case, I want to move right, same 3 units, and I'm going into the village, and this is the same for every other level. Okay, so now let's test if the routine is working. So I have here my game running, and if I try to go to one of the portals, I get the message of the new portal, but for some reason the camera is not jumping to that portal. So let's see what's going on. The problem that we have here is that whenever we create the boundaries of our confiner, Unity is going to create a cache that contains all the confiners pre-computed on the screen. And that means it's going to need to have a specific amount of memory allocated for that purpose. And this works well for the small levels, but this one is a big level. For bigger levels, that default amount of memory is not enough. So we need to tell Unity that Unity needs to allocate more memory. So for us to do that, we go to camera, and we have here an oversize window. So you check this option. You might even specify a max amount of size if you want, or if you keep it 0, you are basically saying Unity you can use whatever amount of memory you want. This is good that you on one side that tells Unity that whatever it is the memory needs, it's going to work for your game, but it's bad that might waste a lot of memory depending on the complexity of your game. So use this with advice. Also, we have this slowing distance that basically means that the size of the zone where the camera is going to start to slow down when they approach the boundaries, the bounding shape of the container. So if we have this number bigger, the camera will start to slow down way ahead of the edge. If this number is smaller, we get the camera walking at a regular pace until the boundary. What I experienced when I test this game is that if I give this a number that is too big, sometimes the Unity might start working a little bit hectic. So what I do in my game, I put this to 0. I don't slow down at all when I'm going to the boundaries of my game. Okay, so if you start to getting some weird results, try that, or try reducing the amount to smaller numbers, or even set it straight to 0. And now let's try again. So move my character, and there you go. We jump to another level. So now I'm bounded to the garden instead of the village. And if I reach the portal, I jump back to the garden. Let's try to go to another one, just to make sure it works in more than one level. And there you go, I'm inside castle, and I can go back to the village as well. So it's working.